This video is an introduction to functions. A function can be thought of as a machine which accepts an input, does an operation on it, and then produces an output. The analogy goes like this. Our machine is drawn as a box with outputs on the right and inputs on the left. Now we can't see what's happening in the box, but there's some kind of process being carried out. And so every function has a rule for how it processes inputs, and it's often in the form of an algebraic equation. So we've got our inputs over here and our outputs over here. Okay, so imagine we're going to feed the machine with the number 3 and put it in the left side. And what comes out on the right side is the output, and that's going to be a 4. The rule for this particular machine is to just add 1 to the input. And the formula for that is just x plus 1, where x stands for the input. And then the plus 1 means we're going to add 1 to it, and that'll give us the output. That's the rule that we're going to follow. Now, in order to write our function in function notation, we want to say that f is the name of the function. So over here, the outputs have the letter f. The inputs have the letter x. Now, just to make it really clear what our function accepts as inputs, we can put parentheses right here. And then x, all that means is that x is the input to the function. Now, inputs and outputs of a function can actually be put into coordinate pairs or ordered pairs. So this combination of 3 and 4, we see that x is 3 on the left, and then f is 4. But this is f of 3, meaning 3 was the input, and the 4 is the output. That's how you'd write it. To put them into a coordinate pair, which is an ordered pair, we can write it like this. 3, 4, where the 3 is the input and the 4 is the output. And so generally, any ordered pair would come in the form of x, f of x. Let's see if we can come up with some other ordered pairs that would work for this function. It says here that in a function, the output can depend on the input. And what you get out of the function is often based on what you put in. So for this reason, it's conventional to let the input variable of the function be the independent variable. And the output variable is often called the dependent variable. So what if we were to throw in a 6 on the left side? Let's try that. If you throw a 6 in, what output do you get? Well, the rule says take the input and add 1. So we would get 7. So in order to write this, we want to write f of 6 equals 7. What that means is that 6 is the input, and we do the operation, which is to add 1 to it, and 7 is the output. Now, if we want to put them in coordinate pair form, it would be 6, comma 7. Input comes first, output comes second. All right, let's try another one. How about if we put in a 0? Throw 0 into the machine. What comes out? A 1. That coordinate pair would be 0, comma 1. And let's do one more. F of 1 equals 2. Okay. The equation below, y equals 3x, describes a mathematical relationship between the variables x and y. Now in calculus, to emphasize that an equation represents a function, we can use function notation. And that's what we had used in the previous example of f of x equals x plus 1. In this case, the formula is to multiply 3 by the input. So whatever number we put in on the left, a number that's 3 times as big is going to come out on the right. That's what this says. So what if we do find f of 1, f of 2, and f of 3? I'll do the first one, and then you can try the next two. Okay, if I throw a 1 in on the left side, a number that's 3 times as big has to come out on the right side. So what comes out? 3. And that's the answer. Try the others for yourself. All right, you should have found that if you throw a 2 in to this function, what comes out is 6. And if you throw a 3 into it, what comes out is 9. It's a function which triples the input.